Okay, YouTube, in this video we're going to just look at another example, excuse me, of solving a system of linear equations algebraically by the addition method. But just a couple of examples here where they're a little bit jumbled around, and you'll see this from time to time. They say, okay, well, here's your system of equations, go solve it. It's a little bit difficult when it's not written in standard form. That is to say that if we're going to use addition method, we want it to be written in this ax plus by equals c form. And so with both of these equations here, what I want to basically imply is that we would have to subtract 7y from both sides in this first equation to rewrite this as 2x minus 7y, and this would be equal to the negative 17 that would have been left on the right side. Now likewise here I would have to add 3x to both sides of this equation, but essentially moving the 3x back over to the left, we would say positive 3x, okay, plus positive 5y here is equal to this 17 that was left on the right hand side. So looking at this, we could say that these really it's the same system, okay, same system. And so because it's the same system, then we could just go ahead and solve it instead of this right here and get the same solution. So let's go ahead and do that. Now, I do recommend using addition method here, but you could certainly use substitution method. Now, because the directions say addition method, that's what we're going to use. But I do want to make the note here. Basically, it wouldn't be very wise to use substitution in the first place, because recall that with substitution, what we're essentially doing is isolating x or y in any of these equations, which in this case, because the coefficients, none of them have a coefficient of 1, then it's going to be really, I guess it's going to produce a lot of fraction values, rational values. So what we're going to look at is using elimination or addition method instead. So now when I look at this system, the first thing we want to do is essentially determine whether or not we want to eliminate our x's or eliminate our y's. Right now, if we were to add these equations together, nothing would cancel out. But if we were to say multiply, say, both of these equations by some non-zero number so that it would make it so that our coefficients were opposites of one another, then that would be a lot more beneficial. So I noticed that 2x and 3x here, maybe what I'll do is I'll take the top equation times a negative 3 and the bottom equation times a positive 2. And that way, when we distribute this here, what we'll get on top for our x's is a negative 6x, but here we'll get a positive 6x. So redistributing here and rewriting it, we get a negative 6x in our first equation plus 21y equals now negative 3 times a negative 17 would be 30 plus 21 is 51 positives. Now distributing here, I suppose we would get 6x's plus 10 y's would be equal to 2 17's, which is 34. So adding these together, you can see that accomplishing our task, basically making our coefficients opposites here, when we add these together, we get 31y is equal to 51 plus 34. I suppose that would be, let's see, a 5 and 8, 85. So one of my favorite things happens here. We get to something like this, in which we would certainly divide both sides of this equation by 31. And we end up with the fact that y is equal to 85/31. Are you serious? Okay, well, hey, you know what? Not a big deal. And it's not a big deal. I'm actually going to write solution right now. Solution. We know the y value. The y value is 85/31. So when you end up with something like this, first thing I'll tell you is that, okay, all right, I'll admit it. As a math teacher, I give a lot of examples that end up with this nice, pretty integer answer values. But I also want you to know that sometimes you're going to end up with values like 85/31, and they're going to be right. But most of the time, you should probably check an answer like that out when you're done. But that's okay, because we check our answers anyway. So now, looking at finding our x value here, I suppose that if I'm looking for x, it's a little bit easier to solve for x in this first equation. We had 2x equals 7y minus 17. Now, I know the value of y now. We say 7 times our substituted value minus 17, we would have 85/31. And so not very fun here, but what we end up with is essentially this. Let's get out a calculator here. I suppose we would get 7 times 85 would be 595. We have 595/31 if we multiply these straight across. And now guess what we get to do? We get to take 17 wholes off of this. And so because I want a common denominator, I'm going to go ahead and take both of those times 31. So we get 595/31 minus now 17 times 31. We have 17 groups of 31 is 527 total. So 527/31. So what this means is now we could say that, 31st, how many? 595 minus 527 basically would be 95 minus 27. If you think about it, it would be 68. So we get 68. So if this is 2x, now here's the fun part. We get to divide this whole thing by 2, or in other words, 2/1. So what we're going to get here is instead x equals 68/31 multiplied by the reciprocal of 2, which is 1/2. And I notice here that these share a common factor of 2. So I'm going to make this a 34. In other words, what we get is we get 34 31st. Now, that's our x value. Fun, right? 34 31st. I'm really, really curious to see how well we did on this right here. And so I'm going to go back and I'm actually going to graph these standard form equations here. 2x minus 7y equals negative 17. So let's go take a look at it. 2x minus 7y equals negative 17. So we have this equation here. And our other first equation was 3x plus 5y equals 17. So 3x plus 5y equals a positive 17. The question is, what is their common solution? So we get this point right here. And I guess what I want to point out is that on our algebraic solution, let me re-highlight that here. Algebraically, our rational values are 34 divided by 31. So that would be just a little bit bigger than 1 for our x value, which this supports. And also that we get for our y value 85 over 31, which I know 31 goes into 85 at least 2 times. So we should get 2 and some change here. And this would certainly be really, really easy to check just by taking, say, 34 divided by 31. I just want to show you that you do indeed get this value, this solution value right here. At least Desmos is going to give it to you after 3 places in this particular case. So hang in there if you get rational values. And also, if it's not written in standard form already, make sure you do so to begin with. Cheers.